Hello, my name is Eric Hofstetter. I'm a student in Professor Shax's Physics 2211 class. I attended the public lecture on the physics of breakfast, which was given by Peter Junker on November 30th. Peter Junker separated his presentation into three parts. These parts were coffee rings, scrambled eggs, and Cheerio clumps. The science behind the formation of coffee rings was only recently discovered. The higher density, darker ring that forms during spilled coffee's evaporation is a result of surface tension and pinned edges. During evaporation, fluid within the drop of coffee flows from the middle, highest point on the drop to the drop's edges to minimize the drop's surface area. The drop's edges don't move during this, as the edges are pinned in place to minimize the surface area. The flow of fluid to the edges concentrates the oils and pigments dissolved in coffee along the edge of the drop, forming coffee rings when all the water is evaporated. The next section of the presentation, scrambled eggs, involves the question, why do scrambled eggs harden as they are heated when most materials soften when they are heated? Junker explained that the proteins within the eggs have water-loving and water-hating sections. In an uncooked egg, these proteins are folded with the water-hating portion within the fold, separated from the surrounding water. When the egg is heated up, these proteins unfold, and then the different proteins in the water randomly stick together to form an elastic gel, which is harder than the separate proteins in the water, unconnected. The last section of Junker's presentation explained why Cheerios clump together when in a bowl of milk. The cause of this clumping effect is due to the meniscus that forms between the Cheerio and the milk. This meniscus is due to adhesion, and it's sloping upwards as the Cheerio is less dense than the milk. To decrease the total surface area of the milk, two Cheerios on opposite ends of the bowl will clump together because, if you have two meniscuses, that's more surface area than when the Cheerios are clumped together because there wouldn't be any meniscus on one part of them. After the lecture, I thought of something to challenge Junker's reasons regarding why eggs harden. I thought that since the water is evaporating when you heat up the egg, this would be at least partially the cause of why the egg becomes harder as it gets cooked. I tested the effects of water loss by boiling an egg and measuring the difference in masses between the raw and boiled egg. The raw egg was 56 grams and the cooked egg was about the same mass, but it was still harder. So I guess it reinforces the idea that the proteins getting mixed together is the reason it hardens, not because it gets denser due to loss of water.